Hello everyone. In this session we'll discuss another question on increasing and decreasing function. So let's see, for a function y is equal to x to the power of x for x greater than 0, we have to check for the interval of increasing and decreasing nature of the function, right? So of course, if this is y, or let's say if this is f of x, anything, if this is f of x, then we need to find the derivative, and then we have to check whether for what region or for what interval it is positive or negative. So for this y is equal to x to the power of x, the derivative will be, before taking the derivative for this x to the power x, we can take log on both the sides. So this will become ln of y is equal to ln of x to the power of x, which will become x into ln of x, right? Now differentiating will get, this will be 1 by y into y dash equal to x will give you ln x, and x ln x will give you x into 1 by x. So that means y dash becomes y into ln x plus 1 by x, or you can say this y dash is, y is x to the power of x, this is actually 1, right? Sorry, this x into 1 by x becomes 1. So this becomes ln x plus 1. This is a standard result also, and if it is okay, you can remember this, that differentiation of x to the power of x with respect to x is given as x to the power x into 1 plus ln x. You can remember this. Now again, so this is y dash, and we need to check the nature of this derivative, and also this x is given to be greater than 0. In that case, you can see that splitting into this two half, this function is always going to be positive, right? Because x is greater than 0. So this won't change the nature or the sign magnitude, sign sense of the function value. So this is the only function which will matter now. So we should check for this function so that we can find whether the function is increasing or decreasing. So let's talk about for 1 plus ln x. Now we know that ln x, 1 plus ln x, so we'll have to equate it to 0 so that we can find that point below or above which it is going to be of different sign. So let's say for 1 plus ln x is equal to 0, we can say ln x should be equal to minus 1. So ln x equal to minus 1 makes x is equal to e to the power of minus 1. That means for x greater than 0, the root e to the power minus 1, below and above which we can have the change of sign of the derivative. So we can check, let's say for any value less than e to the power minus 1, this value is going to be 1 plus ln x, so this is going to be 0 and e to the power minus 1. This ln x will have more negative sense than the 1, so in that case 1 plus ln x will become negative. This 1 plus ln x will become negative, and you can check it for any value. If you want, you can check it for, let's say, x is equal to e to the power of minus 2. You can check it, you'll find this value to be negative. Similarly, this means for x to be greater than e to the power minus 1 and since they don't have upper limit, so we'll keep it like this. In this case, this 1 plus ln x will have a positive value, right? Anything greater than e to the power minus 1 will give you a positive sense. So in that case, this function f of x is going to be decreasing. When I say decreasing, I'm not talking about strictly decreasing, right? We are including f dash of x equal to 0 and f dash of x less than 0, right? If it is strictly increasing or decreasing, it will be always mentioned. So we can take for f of x to be decreasing, the interval can be 0 to e to the power of minus 1. You can, or if you want, you may not include this interval, because if you are including e to the power minus 1, this term 1 plus ln x is going to be 0. So that is also okay, because in that sense the derivative of f of x will be 0. So if we are not talking about strictly decreasing, then this derivative to be 0 is fine. Similarly, this is going to be increasing if we have this region, let's say e to the power of minus 1 to infinity, because the upper limit is not mentioned here. It is simply x greater than 0. We are talking about x greater than 0. So we can take any value higher than e to the power minus 1 also, right? So now this makes it clear that in what interval this function is decreasing and in what interval this function is increasing, right?